students. So we are going to start with our third module. So that is the knowledge representation, or we can say knowledge inference. So when you look into the what are the topics we are going to cover in this particular module is we have got certain introduction to the knowledge representation. Then what is it mean by a production based system? Then we have got frame based system, inference, that is we are going to look into the backward chaining and the forward chaining, and some of the uncertainty knowledge, how we are going to deal with uncertainty knowledge. It can be a fuzzy logic or certainty factor. So these things will be discussed in detail in this particular section. So when we are going to start with the knowledge representation, so in the previous module, so we have discussed a lot about the knowledge representation and the various inferences. What is the knowledge, what are the important properties of the knowledge. So let us just try to look into a brief overview. So what do you mean by a knowledge? We already have defined that knowledge is nothing but it's a collection of some facts or interface. So we are going to see that these particular knowledges are nothing but some facts, generally what we are going to have. Then certain inference rules will be we will be having our inference rules. You can talk about the inference rules, etc. So it requires, so when we are discussing the knowledge, we know that it has got various features. So some of the very important features we have already discussed. It is very vast, knowledge is very complicated, it keeps on changing, etc. So the basic component of knowledge, we can see that it has got some set of collected data. So that means we have got certain facts. So all these facts we are going to call it as a knowledge. So it's a form of belief or certain hypothesis. Sometimes we may talk about an hypothesis. So we say a fact. Now that particular fact can have separate values later when we are going to talk about. So when we look into a typical knowledge based system, so knowledge based system generally it gets its power from the expert system. So later we'll be discussing what is an expert system and how actually it is going to work. So when we are talking, as the name suggests, knowledge based system, the knowledge is very important for us. So the knowledge is stored. So we are going to store these knowledges. The knowledge is stored in a knowledge base. So we try to store the knowledge in a knowledge base rather than calling it as a database. We are going to call it as a knowledge base. So generally from the external environment we give certain inputs, right? So whatever the inputs, it can be in English sentences or statements. Now that English statements has to be converted into an internal representation. So already now we have discussed these things. So how it has been converted to English representation, or we can say the internal mapping where the inference engine comes into the picture. So once these from the external entity, when the knowledge goes inside to our particular system, so then the processing of that knowledge starts. That is where the inference engine comes into the picture, or inference control unit. So where actually all these knowledges are being inferred. So once either directly we are going to take these knowledges from the external environment to the inference engine, or already previously if you have collected this knowledge in your knowledge base, from this knowledge base also we are going to consider these inferences here. So that the inference engine starts working on that, and where you are going to infer or conclude on certain things. So this is how typically a knowledge system looks like. So when we are talking about the knowledge representation, as you know that it is a very important part in any AI, or you can say any development of any system. We need to know how the knowledge is been represented. So it's not just like English statements or sentences we have in a real world entity. Now these things has to be converted into a knowledge representation. We need to have a system. So we have started already in the last module. So we have seen some of the knowledge representation schemes also, and basically we also discussed a few very important properties of the knowledges. Like say when you say that okay, you have built a knowledge based system which is very good, how do you compare? So we defined 4 important properties, like say representational adequacy, that is then the inferential adequacy, inferential efficiency, and acquisitional efficiency. So we have discussed all these things. So where the ability to represent the required knowledge, representational. So is it possible for us? So when you build a particular system, is it possible that all knowledges what we are having, can it be represented? Everything do you have the ability? Do your system has the ability to represent all the knowledge? That's the representational adequacy. Inferential adequacy. Now can you able to manipulate all these knowledges which are stored in your knowledge base? Are you able to infer and produce a new knowledge, right? So you have some set of certain knowledges. So from that knowledge, can you infer something? Can you deduce something? Can you make a conclusion on some new facts or new knowledges? That's what talks about inferential adequacy. So your system should be in that particular form. Then we have got inferential efficiency. Talks about our, the next 2 points talks about the efficiency. So do our knowledge base system has got certain property wherein which in the ability to infer, that is the mechanism what you are going to store, is it efficient enough, right? It should be very efficient. It should not happen that today it is giving you some results or some conclusion you are drawing and tomorrow the efficiency is not proper, it keeps on changing. It should not happen. Similarly, acquisitional efficiency, how far are the ability to acquire new knowledges, so which we talk about the acquisitional efficiency. So we have discussed these 4 important properties of our knowledge representation, and this particular diagram clearly shows that the relationship, or you can say how the mapping is been done from our real world. So from our real world entity, so we are going to take the English sentences and convert represent those things in our facts, some internal representation. Now when we have got these internal representation, so from here these statements have been taken into the inference engine. Now the inference engine, just like our brain, here we have got an inference engine which starts working on that particular knowledges. It infers something, makes some conclusion. So you are going to draw certain new conclusion, and this conclusion once again it goes back to the real world in again English sentences. So overall we can say how we are going to have the syntax and semantic, or the relationship which exists between our knowledge, that is external entity, and how we are going to convert it into internal representation. So when you are talking about these type of knowledge representation, it can be represented in different way. So already in our previous model we have we have discussed what is the first one of the very basic thing. What is first one is called as the propositional logic. So propositional logic. So we have already discussed in detail, or in a very simple terms we have discussed propositional logic. Then we started working the drawbacks of propositional logic, why we went to FOPL, that is the first order propositional logic or predicate logic. So these are the 2 knowledge representation already we have seen in our previous module. So now in this particular module we will be looking into some other knowledges, like say rule based system. So or what we are going to call we have got production rules. So we have got some rule based system representations are there. We have got frames, we have got semantic network, conceptual dependency, scripts. These are some of the different knowledge representation schemes we are having. So now we are going to start with one of the another basic knowledge representation scheme, which is called as the production based system. So when you are talking about a production based system, so what is this? It's also called as a rule based system, right? So the alternative name, or it can also be called as a rule based system, and the name implies that rule based. So we have got some rule. So what it says, that a system whose knowledge base is represented in set of rules and facts is called as a rule based system. So when you are saying about the representation, so we say that it is a production system is such a type of a knowledge representation system where the rules becomes very important. We have got some set of rules. So we will be having some facts, we will be having some rules. All these rules are been stored. And how does this rule? So a set of if then. When we are talking about the rules, generally the rules will be in type of if then statement. So in our programming language we know that how we have got if then. So in any of the programming language we try to use a simple condition statement, is that if today if it is raining, say for example if you say if it is raining, go with an umbrella or take an umbrella, right? So you have got some if then statement. So typically any rule based system, it consists of some rules. So now these rules will be in terms of or in style of if and then, right? So now we have got certain conditions. If these conditions holds good, then you have to do some action. So left hand side we call it as a condition. So generally rule based expert system is one such a technology which is being used extensively in various applications in of our AI. One of the important application where this rule based system comes is called as an expert system, so which we will be discussing in our later system or later modules. So when you are talking about this rule based or production based system, now it has been have a lot of implications in various applications as when we are talking about a knowledge based system. Now when you are going to consider any rule based system, so it generally the rules what we are going to have, let me take our pen. Okay, so generally when we are having the rule based system, now it can be divided into two things, or we say that generally two things are there. So one is the rule based system, we have got a knowledge base and the rules and facts. So what is that? We will be having some rules. When we are talking about rules, now how these rules will be, that rules will be in terms of if then. So just like how we are having if then statements, so all the rules will be in the terms of the if then statement. Then we have got some facts. So not only rules, so we also have some facts we will be having. So one is the rules, so which is having an type, or you can say an example as we have seen. So you have got some if, so we will be having some conditions. If this condition is met, then it triggers an action. So if then, so we have got this. The second one is, so we will be having some facts, that is assertion that represent the domain knowledge. So we know that once you are talking about a domain, so we should have some domain knowledge will be there. So now we are going to have those domain knowledges also. So when we talk about the rule based system, now everything in our knowledge base, when we are talking about this, we have got facts. So there will be some goals, and that rules will be there which are to be inferred or manipulated so that you are going to achieve your goal. So like say when we are talking some of the applications like say lexical analysis or compiler interpretation or natural language processing, so generally here we can extensively use this particular system. Now when going further, so this rule based system, rule based system consists of three important elements are there. The first one is set of facts. So now we have got some set of facts will be there. Let me go down. Okay, so now it consists of three important components. The first one is called some set of rules. So what are rules? Already we have discussed. Now what are the various rules we are having? Okay, so we have got some set of rules. Now these are certain assertions or anything relevant to the beginning state of a system. So we will be having some set of facts, some knowledge is being given. Like say for example, today it is raining, or today the humidity is more, right, the temperature is this much. Some facts are there. So then we'll be having certain rules. So if the humidity is too high, or if you find it's too cloudy, then take a umbrella or go with an umbrella. Some rules will be there. So we have got some facts will be there. The second one is set of rules. Now it contains all the actions that should be taken. So what are the actions you are going to take? Right? What are the actions we are going to take within the scope of the problem or in our particular domain? And it has got the form if then, if and then. In that particular form, all the set of rules are been written. And the third one is termination criteria, or we can call it as interpreter. So the termination, just like any program, you know that we need to terminate. So when you are going to say, when you decide, when you keep on applying 111 rule from our knowledge base, you have to terminate something, or you should come to a conclusion. So what is your result? So for that we have got some interpreter, or the third, that is determination criteria. It determines whether the solution exists for our particular problem or not, or when you want to terminate the program if you are not able to get the solution, or if the solution comes, okay, I got the solution, so you can try to terminate. So these are the important things which comes into our production based system. Now let us try to understand each one. We'll go in a more detail of these particular points. The first one is set of rules. It is very simple. We will be having a lot of rules are there, each rules related to that particular domain. Like say if you are talking about certain expert system or production based system which is medically in area, so diagnostic systems are there. So where depending we will be writing rules which are related to that particular diseases or for what you are going to do. So domain specific rules should be there. So that is the rules will be there, and all these rules will be in if then statement, right? So this is the first, the second thing. First thing is facts, all the domain knowledge. So now when you are talking about rules, as we were saying, now the production rules, when you are talking about the production rules, it consists of if then expression. And how does it have? Now if conditions. So we will be having one condition, or you may have more than one conditions. So if condition exists, if it satisfies, then you have to perform some actions you are going to form. So generally we can say it is like a condition action pair, key pair value, right? We have got some conditions, you have got some pairs, action will be there. If these conditions are satisfied, you do this action. So conditions means what? So these are the pattern that determines when a rule may be applied to our problem instance. Now it is going to tell. So you check if right condition is what? It is like a pattern that determines when I should apply this rule. So you have to compare your left hand side the pattern, and you are going to check, okay, now I am going to apply this particular rule to a particular problem instance. You are at one particular state or from initial state. Now if you remember in our first module we have discussed one of the problem called as water jug problem, right? So in our water jug problem we have written some rules. So now if you are going to apply rule number 1, you have to check whether can you apply the left hand side of the rule, whether the condition is it matching. If the condition matches, then you apply, then you go to the right hand side, some action you are going to perform. So left hand side we call it as a condition, then we have got action, so which defines the associated problem, or which defines what the action you are going to do it. So in other terms, it's the left hand side is also called as antecedent, and the right hand side is also called as consequent. So we have got antecedent, so and as well as the consequent. So apart from a simple rule, now we can add certain connectors. So we have discussed already, right, in our logic, mathematical logic or propositional logic. Now you can add certain connectors. You can combine two rules. So today if it is raining and right, Rama went to the school, now you are going to combine these two things. So we will be having, so we can have if antecedent 0 or condition 1 and condition 2 and condition 3, how many conditions you have got, you can combine using either an conjunction or a distinction, that is AND operator or an OR operator. If all these, when you use AND, if all these antecedent matches, if it is true, then your consequent is going to follow, right? So even not only you can have a multiple antecedent, you can have a multiple consequence also, that is right hand side. So you can do more than one action at a time. That type of rules also can be written. Now if you take a simple example, now say that you have got one rule. What it says, if high temperature, then prescribe paracetamol or aspirin, right? How does the doctors is going to diagnose? So they look into our body temperature, how much temperature we are having, so we get some values. Now again the rule says that if your temperature is greater than 100 degree, if temperature, what value you are going to get, if it is greater than 100 degree, then prescribe paracetamol, like this. Or say for example, if the temperature is greater than 200 degree and now we are having more than one antecedent, left hand side conditions are more than one. If it is greater than 200 degree and water level is low, then open the safety valve, some action you are going to perform, right? This is how we have got some facts, we have got certain rules. Now let us try to look more about the inference mechanism, the third one. what we are talking? So we are talking about the inference mechanism. When we are talking about inference mechanism, generally a production system, it uses something called as a working memory. We know that we should have a memory because we are talking about knowledge base, we have to store it. So in our knowledge base, we will be having some facts, we will be having some rules. All these things related to a particular domain, it is stored in a memory, which you are going to generally call it as a working memory. And from that working memory, next process our inference starts. So in this, but this is very important, right? You have knowledge, you have all the facts, you have got all the rules, everything is stored properly, fine, but how to work on that? You need a mechanism, you need a mechanism which is called as an inference mechanism. In general, we can call it as an inference engine. So this inference is accomplished, or what do you mean by this? It is a process of chaining through rules, right? It is stated that it is a process of chaining through rules in forward or backward direction. That means you can start applying the rules in a forward direction, that is from goal to the, from initial state to the goal state, or from a goal state to the initial state. So later part we will be discussing more when you go to the rule based system, right? That means when you are taking some of the examples, now how we are going to actually infer the things. So we can have either a forward or a backward until we are going to satisfy the conditions of the goal. So this selection, so once you are having, it is just like an iterative process. You keep on applying the rule, like say water jug problem we have discussed, right? You start with an, you are going to, when you are talking about a water jug problem, so as we already let me take the pen. So when you are looking at the water jug problem, what is your initial state? Your initial state is 0, 0. From initial state, you need to reach your goal state, right? So you should get a 2 liter water in a 4 liter jug, or whatever may be the problem domain you are having. So you are only interested in 2 liter in 4 liter jug. This is, we can say, this is the final goal. This is your initial state. So now to solve this, you have written some rules. So you might have written so many rules you are going to write. Either you can start from initial to a goal state, or you can go from a goal to the other state. And when you are selecting the rules, so already we discussed the control system in our previous module, right? So what is your important, or the concept in our control system says that is a rule applier in our production system, right? When we are defined a production system, we defined one of the important concepts there is the control system. So that is how you are going to select the rule. So there should be some systematic, there should be some flow, right? So we have seen all those important things. So selection of a rule, now it is determined by how you are going to select. It is determined by matching the current fact against the domain knowledge or variables in our rule and choosing a best candidate rule. So you have got your domain knowledge, or what we say, you have got your knowledge base, you have got some set of rule. Now you are going to match it. Whether if you take first rule, okay, the first rule what it says, you are going to match it with the current state. If the current state is matching, then you apply that rule or select that rule and you keep on applying. So like this, you keep on applying one by one rule, and you go from initial state till the goal state until you are going to reach your goal. So then when you are saying that you are applying these rules in a systematic manner, that is your inference process starts now. So another important thing comes here, triggering. That means you have to trigger that rule. So you know that, okay, this rule if I apply, it meets the left hand side. Now I can apply this rule, but how you are going to apply it? Rule applier, already we have discussed. So the fourth one is rule applier. Similarly here, what we are talking, that is the triggering. You have to trigger the rule. A rule is triggered when all the left hand side becomes true, when it is evaluated. So when these left hand sides are evaluated to a true, so your rule is been triggered. So a rule is fired, so when the action based on your left hand side, so once it is true, then you trigger that rule. Once the rules have been triggered, actions is going to follow. So this is the what we are talking about, a production system. Now let us discuss in general how we are going to build a particular production system. Now you can see here this particular diagram clearly gives us a representation how a production system says. So you can see here there are three important we can say the modules which comes here. The first one you can look here. So we have got something called as control scheme or interpreter, right? We have got something module called as a control scheme, which is very important, or it's also called as interpreter. So then the second we have got condition action ruler, or what we say rule applier. So we need to have some rules. Already we said rules should be there. Then we have got database of facts. So where we'll be keeping all our rules and facts in a knowledge base. Knowledge base is there. Then we should have some rules, appliers, and interface engine, inference engine, sorry, what we told, inference engine, that is nothing but our interpreter. So now let us try to understand these things. So now what we said, the first we have got a database, right? So we have got some database now of facts, where all the facts related to a particular domain are being stored now, which is used by our interpreter for inferencing or inference mechanism. So we can see in this diagram from the database, so you are going to, the interpreter or inference mechanism pulls the knowledge which is stored in our knowledge base in terms of facts, right? So then it also takes from our rule. So next what it does is that we have got some set of rules like if then condition. So from one side it pulls the facts, the other side it pulls the knowledge, then it is going to work. Then we try to do the inferencing, so which is been done by the control system or interpreter. So this inference engine or the interpreter, or it's also called as control system, is a very important thing. So when you look into this particular control system, so what is the control system, or how does our inference engine is going to work, or inference mechanism is going to work? Now it is a very important thing. Now when you look here, our inference mechanism, it is broadly divided further into three steps. What are these three steps? So we have got a matching stage, we have got a conflicts resolution, and execute. So these are the three important or the steps which is being present in our interpreter. Now let us try to understand one by one. Of course, these are very straightforward and very simple things to understand when you take a simple example how actually we human beings are going to process in our brain, right? The first thing is that match, right? Now what does this match says that? Now in our inference mechanism, now inference machine is going to compare the fact based, that is facts what is there in our knowledge base, and the rule base, and find some rules are matching. So now already we told the rules are how it is like if then statement. If condition has to match, so how do you match that condition? You are going to do a matching here. Like say when you are talking about searching an element in an array. So you have got an element, you want to search an element, you store that element in a variable, and you are going to say equal to, if x is equal to or key equal to a of I, you do a matching process there, right? So that is what it says that. Now inference, our inference mechanism or matching is nothing but comparing the facts which is there in a knowledge base and the rules. You have some rules. Now these rules, it should be compared with this. If it is matching, then we go to the next step. So these set of rules are passed to the next phase. So once a matching is been done, okay, this rule matches with our current state and our knowledge base and the database, everything if it is matching, then it goes to the next stage. So once the matching is done, then it goes for conflict resolution. Now this is a very important phase. Now what does the conflicts resolution says? Now as the name tells us that sometimes it may happen for us that there might be more than one rule which is going to obey the LHS or left hand side, the condition, right, antecedent. So you might be having more than one rule which satisfies that. So that time which rule I have to apply? There is a conflict. So the system get confused. Like say for example, now you can see here we have got rule 1. What does the rule 1 says? If the traffic light is green, then take an action, go. Right? If the traffic light is green, then you have to action is go. The second rule says that if the traffic light is red, then the action is stop. Okay, both the rules are different. Now you look into the third rule. The third rule here, it is saying if the traffic light is red, then action is go. Now you see, if you take your first rule, which is telling that if the light is green, it is telling go. Second rule is telling that if the light is red, then also the action is go. Now here, and if you take your second rule, if the light is red, now observe, look carefully. First time when you are taking rule 1 and rule 3, the right hand side action is go, that is okay, but left hand side you have to match. We have to see that whether the signal is green or red. Now you look the second rule. If the second rule comes into our knowledge base, if this rule comes into our knowledge base, now there is a conflict between second rule and the third rule. Now what is the second rule is telling? If the traffic light is red, then stop. The third rule says that if the traffic light is red, then go. Which one to follow? Because in our matching process, what we are doing, we are just taking the left hand side and we are going to match, and it says that okay, traffic light is now red. So the rule, when you look into the second rule, red, actual traffic light is red, it matches. Now when you go to the third rule also, it is also matching. Now in these two, which one to apply? If you apply properly the rule 2, you are going to stop because it is a red light. But by chance if you go to rule 3, then it is giving a wrong information, the inference engine. So what has happened right now here in this example is that there is a conflict. So now we are going for a conflict resolution, because in many of the times in our inference engine, when we have got more rules, so there will be certain conflicts. How to deal with this particular conflicts? So how we are going to deal with this conflict? So when we are talking about the conflict resolution, so we have got few different types in which we can try to do. So you can see here the first one of way how we can try to resolve this particular conflict is recency. Now what does this recency say? That rule which use more recent facts are preferred. Now what it says that you start looking into your rule, the knowledge base, and you have got lot of rules. Whichever rules you find which are being more recently or more number of facts are there, right? Those type of rules you are going to select. So in order to avoid the conflict. So working memory elements are triggered, indicating at which cycle each fact was been added. When and how the facts keeps on adding into our knowledge base, which are the most recent facts, and based on that particular fact, if a rule is there, out of those two rules which is having a conflict, so that first rule or the second rule has been selected. This is one way of avoiding the conflict resolution. The second one is specificity. Now what does this specificity says? Rule which has greater number of conditions. Which particular rule which is having more number of conditions? As we have discussed that we can have more than one conditions. So whichever rule which has more number of conditions, now we are going to select that particular rule, and therefore more difficulty to satisfy, because as you know that when you keep more and more conditions, it has to be satisfied. All has to be true, then only you can apply the rule. There are one rule which has only one condition, other rule which has got three conditions, then obviously we will look into the third one, because when you select that, this can be removed, or we can say conflict can be avoided. So more specific rules are better because they take more of the data into the account. Like say for example, now if a particular doctor wants to prescribe a drug or a medicine for a fever, if he just touches our hand and take the temperature, based on that if he is going to give a prescribe certain medicine, is that better, or you add more condition? Not only the temperature, I want to have this particular blood test also, I want to have that test, this test. After looking all these things, I am going to prescribe the medicine. So more specific, right? This is the second way to avoid the conflict. And the third one is called as the refraction. So what does this refraction says? A rule should not be allowed to fire more than once on the same data. So like say in the previous example, we have rule 2 and rule 3. If already that one rule was already been fired, so then we should not allow again this rule to be fired, right? So these that is what we say, the executed rules are being discarded. Once a rule is been executed, so we can remove that rule. Again, if that rule is there is a chance that conflict can arise. So simple thing, once you apply this rule, remove it from your knowledge base. So we can avoid the conflict in that particular situation. The fourth one is rule ordering. So it is very simple. So you try to apply the rule in particular order. First you apply first rule or the third rule, then the fifth rule in some even number of times or odd number of rules. Some manner you can, in a systematic manner we can try to order the rules. Now these are the four different ways. Now apart from this also we have some rules which we call it as where we can use some meta knowledge also. So we can try to use knowledge about the knowledge, so before applying the rule, in order to have the conflict. So you try to have any extra knowledge if you are having, you try to take. So once from a matching you have done of a rule, it goes to a conflict. If there is no conflict resolution, directly you go to the execution phase. You apply that particular rule and rule has been triggered, it has been fired and the action has been taken. If there is a conflict, we have some ways in which you can remove that particular conflict, come to one conclusion, okay, this rule I have to apply that particular rule, or we go to the last phase, that is the execution phase, where the rule has been triggered. So these are some of the simple facts, the simple the base in which the inference engine is going to work, or the control structure, right? So when you are talking about the main production system, so we have got a knowledge base, we have got some rules player or a rules, and we have got our control system or inference mechanism. And when you are talking about inference mechanism, again three things comes. You should go for matching, then conflict resolution, then the third one you have got execution. So this is how, in a very general form, very basic form, you can have a production system, right? So, or a rule based system. Now when you are trying to understand some of the limitations of this rule based system is what, so it can be difficult to create because you should have so many rules, because as you said that we should have so many rules, but still we are not discussed how to apply the rule. Later we will be discussing now how actually the rules are being applied for us. So we are just saying, so when you are saying that okay, I need a production system, I need to have some rules, so you should, depending upon the problem, like say when you are talking about a chess, right, how many rules you are going to write for a chess? So many rules comes. As the problem becomes increases, the complexity increases, it is very difficult for us to create the rules. So the knowledge engineering, what we call the problem of knowledge engineering, comes into the picture. The second limitation is that it can be difficult to maintain. As the rule based system increases, as the knowledge base increases, as you know that it becomes too difficult for us to maintain, to keep on adding new rules keeps on coming, so it becomes very difficult, and many type of knowledges are not easily represented by rules, because we know that there are certain knowledges it is very uncertain, because when you are talking about rule it should be very certain. If this, that is why we say if then, if condition then write a rule. But in general, in many of the applications where the knowledges are uncertain in nature, so when our knowledges are uncertain in nature, so then this particular rule based system is very difficult for us to understand. Right? So till now we have seen another knowledge representation, so what is called as a rule based system. So in our next topic we will be looking to another knowledge representation system, which is called as a frame based system. So frame based system is also very simple way in which we are going to represent the knowledge, or whenever we have got our natural language processing. So we will be discussing these things in our next class. So have a nice day. Bye bye.